Hello friends, I think we should talk about pointers. And I'm gonna give you a few pointers. Now, here's the thing. Why does everyone hate pointers? Well, in C++ there's an obvious reason for hating pointers, is that they're difficult. And in other programming languages like Java, there's far fewer reasons for hating pointers because, well, everything is a pointer. Now, here's the thing. If everything is a pointer, then nothing is a pointer. See what I did there? However, I do think that in order to understand other programming languages as well, we could kind of have a look at what's under the hood in C++ and have a practical comparison with Java. And well, why do I want to do this is actually not because I'm a Java fanboy, for instance. Actually, I prefer Java to C++. Well, the comparison is a moot point, but I think we could have a pretty interesting discussion about this and see why Java behaves in a certain way and why C++ behaves in another way. So without further ado, let's start. So let's start an example, shall we? With the magic of editing, I went ahead and did this. So I've created two classes, one in Java and one in C++, which do exactly the same thing actually. We have a product class with getters, setters, and constructors. So what I'm doing here essentially is, like, I have a product class in Java with an, technically speaking, a default constructor, and I have a constructor with two parameters. I'm just gonna go ahead and write here product two params. So basically in Java, if I go ahead and create a product p1 is new product, well, essentially this creates a product for us and calls the constructor, right? Right. I'm gonna go ahead and do the exact same thing in C++, and I'm gonna write cout product 0 params and line, and I'm gonna go ahead over here as well, product 2 params and line. So I'm gonna go ahead and write product p1 and nothing more. Now here's where the difference already starts. In Java, see, when I create a product, I have the option of this p1 variable being null. For instance, if I don't want to instantiate it right away, I could just go ahead and write this. So what would happen? If we run this code, we get nothing in the console. Well, why does this happen? Because when I create a variable, as long as it is an object type, I have the opportunity to choose between I want this memory now or I want this memory later, right? Okay, C++ also kind of gives me this choice, but not if I were to write it like this. In this case, it goes ahead and says, you want a product right now, you want a product right away, and I'm gonna create this product for you, basically. Whether I were to write it like this, check this out. So it says product 0 params because it creates the product right away. I can't go here and say this one is null, like I did in Java, or this one is null pointer, as I did in Java. But C++ says, hey, you want to create a product? You're going to create it right away. I'm going to create it for you. Now, here's the thing. If I want this to function as it did in Java, I could actually go ahead and use pointers. I'm going to go ahead and use this, right? So the weird, nasty star sign that we all hate. If we were to run this program now, I'd get this output basically. So nothing happens. Essentially, see, in Java, I have everything as a pointer basically, right? This is the reason for which this line of code over here allows me to put null as a value for variable p1. In C++, I could only do this if I explicitly declare the variable as a pointer. See what I mean? Now, the analogy goes further. Allow me to demonstrate. So, in Java, I'm just going to comment this line over here and comment this line over here. So, in Java, say I were to want an array of 10 products. Maybe I don't want to use them now, maybe I want to use them later. But I could write this. Products array is a new array of product of length 10. Fair enough. Seems okay, right? Now, taking into account that Java isn't eager to create the products, if I were to run the code now, see, the console doesn't give me anything, doesn't show me anything, and everything is pretty okay, right as rain. Let's try to do the same thing in C++. So, products, and I'm going to use the old-fashioned way. So, this would be an array of 10 products. Now, here's the thing. These are 10 elements of type product. So, C++ will say, hey, okay, you want 10 elements of type product, so I have to have memory ready, right? Remember, as we did in this case, product P1. C++ eagerly went ahead and allocated memory for the P1 variable, right? Well, it's kind of gonna go ahead and do the same for the product array. It says, okay, you have 10 dedicated spots for products. I have to make room for them, right? Check this out. So, told you that would happen. Make sense so far? I sense that as a yes. Anyway, so Java thinks of this array as it being like this. Null, 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 so on and so forth. And, well, it has basically 10 nulls over here. We could have a little bit of an experiment to make sure this is the case. For each product, I'm going to call this P in the products array. I'm going to go ahead and write to the console product P. Check this out. See? Told you this would happen. Now, in the case of C++, it already allocates memory for 10 elements of type product. However, what happens if I don't want to have 10 products right off the bat, right? Maybe I would like for the same equivalent as in Java to happen here. Like C++, don't worry, don't hurry with the memory, right? Allow me to first inform you that I want space for 10 products, which may also be null. Well, that's where the tricky part comes in. So it doesn't suffice for me to say I want 10 elements of type product. This would make C++ overly eager. So I want 10 elements of type product pointer. Remember last time we ran this program? It showed on the console product 0 params 10 times. Well, let's give it a run again. See? It's not eager anymore. Does this make sense? I certainly hope it does. Let's have another experiment, shall we? So, check this out. In Java, I'm gonna go ahead and name this one main old, as I'm gonna do in C++. This one is gonna be main old. So, I'm gonna create in Java a method, like main, and I'm gonna go ahead and create a product using this constructor over here. So, let's do just that. Product P1 is a new product, and I'm gonna name this pizza, of course, with a price of $29.99. And I'm gonna go ahead and create another product P2. But am I gonna create another product? That's debatable. I'm gonna go ahead and write this P2 equals P1. So, because I've added this new method over here, the toString method, if I display P1 and P2 over here, the toString method is gonna be called, and we're gonna go ahead and get this output. Now, what's interesting about this in Java? Mind you, we're dealing with pointers, right? So in Java, everything is a pointer. So what were to happen if I were to go ahead and do this? after I've assigned P1 to P2, I'm going to go ahead and change the price of P1 to 39.99. So take your time to answer. Okay, time's up. If you might have guessed, well, basically, this changes the price for both of them. Now, why does this happen? Essentially, in Java, when I do this, I get two references to the same memory space. So if I were to change P1, P2, well, basically changes as well. So in Java, everything is a pointer, and pointers are pretty sticky, as we can see over here. Now, let's try the same thing in C++. I'm going to go ahead and create a method, a function over here, a main function. And I'm going to go ahead and create a product P1. I'm going to name it pizza as well, with 29.99. And then I'm going to go ahead and write P2 equals P1. See, it's a very legal statement. Afterwards, I'm going to go ahead and change the price for the P1 variable to 39.99, like I did in Java. Okay, now, mind you, there's a teensy-weensy little weird thing in C++. If I were to do this, cout P1 and line, this doesn't work as expected, because C++ doesn't have the equivalent, the rough equivalent to a toString method. I could go ahead and write a toString method over here and call it. Well, for now, let's do just that, actually. Do you agree? That's yes. Okay, so I'm going to call this one toString, and it's just going to be a void. I'm not going to return anything. And I'm going to write name, and I'm going to display name, and price, and I'm going to display price, and enter, because why not? So we're going to come back to this a little bit later, but I'm just going to go ahead and call toString on P1, call toString on P2. So what's going to happen? Take a second and think about it. So in Java, everything is a pointer. That's your hint. Well, C++ doesn't consider anything to be a pointer. If we were to run this code, it doesn't consider P2 being a pointer. It doesn't point to where P1 does. Essentially, it creates a whole new product. It's a whole new memory space. So if we were to run this, we'll get two different products. Oops, I forgot something. Oops, what did I do? Oh, I'm so very sorry about this. This one. And let's run it again. Ta-dam. See? So when we're modifying, essentially, one object, as we did here, the second object doesn't see the modifications happening. So this is because C++ allows us to choose what's a pointer and what's not, essentially. Does this make any sense? Check this out. If instead of statically allocating P1 and P2, if we were to use just pointers as we have done in Java, look, let's have an experiment. Main old part 2. So I'm going to go ahead and create a main function, but just using pointers. Check this out. I'm going to go ahead and if I want this P1 variable to be a pointer, I can't write it like this. Instead, I have to write it very similar to the Java bit of code. So I'm going to go ahead and do this. Pointer P1 is a new product with these values. Now, remember last time when I tried to do this, it kind of got a little bit upset with me, C++. Why did it get upset? Because it said, you know, like, okay, P1 is not just a string, a double, a char, a float. It's a complex object, right? So when you're trying to display it, what are you actually displaying, right? So in the case of the pointer, if I were to do this, cout P1, see, the problem goes away. Why? Because this variable P1 is not actually a product, it's the address of a product. check this out. I'm gonna run it real quick. See? It displays the address of the product. Now, if I want to go ahead and display it, so we have the toString method over here. I could go ahead and, well, I can't just use dot because p1 is a pointer, is an address, right? So I first have to dereference it to get from the address the actual product, right? And then call toString. See, it would work just fine. And I could write it like this, or taking into account a little bit of syntax sugar, I could write it like this. It's pretty much the same. See? However, if I create another product pointer, p2, and I'm gonna go ahead and say p2 is p1. Now, bear in mind, in Java, when we did this, when we modified p1, this modified p2 as well, because Java thinks everything is a pointer, right? Okay, now, in C++, if we go ahead and do this, it is a little bit like Java. Remember that this case essentially created a copy of p1. It was another object, so calling setPrice on p1 didn't affect the price on p2. Now, if we're using pointers, it is the very same situation as we have in Java. Check this out. I'm just gonna see out a line over here, and I'm gonna go ahead and call toString on p1. Gonna go call toString on p2, but before this, I'm gonna go ahead and say p1 set price to 39.99. Remember, in the last case, it didn't impact p2, right? Okay, let's test it out. See? Both of them are 39.99 in this case. Why? Because we've used pointers, and pointers are sticky. In Java, everything is a pointer. Well, if everything is a pointer, then nothing is a pointer. You see what I'm doing? Cool. So, what do you think about this? Also, please let me know in the comments. Oh, I just remembered. There's also another thing I'd like to show you. Check this out. So, in Java, basically, when we do something like this, we don't get a copy, right? So p2 would be pretty much the same thing as p1. So if I were to change the price on p1, the price on p2 also changes, as we have seen in the console output. So I want to be lazy about it and be able to create another product with, well, basically the laziest way possible, right? So how could I do that? Wouldn't it be nifty if, instead of writing this, I could go ahead and write something like this? Product p2 is a new product, but based on p1, right? So after I do this, p2 will essentially be nothing more than a copy, basically, but a copy at a new memory address. See, Java at this point, it kind of gets a little bit pissed off. Why? Because I have no such constructor. I only have an empty constructor. I have a constructor with two fields, but I don't have a constructor which says, hey man, give me another product, give me the other product, and I'm gonna put the data into this product. So let's go ahead and do this. I'm gonna go ahead and create a product constructor which receives another product as a parameter, right? So for the current object that will be created, I want the name to be the another product's name, and for the price, I would like it to be the another's price. Now, let's see how this changes things. Let's run it again. Ta-da! See what I did here? So I have the product P1. I change the price on P1. This only affects P1. And product 2, P2, when it becomes, well, see, that's the thing, it becomes a whole new product. See, new product, get it? So this essentially would be, in Java, a copy constructor. Why is it called a copy constructor? Because it copies things. It receives another object, and based on that project's values, it returns a new product. See, P2 is going to be a new product with the old product's data, but afterwards, when I change P1, it doesn't impact P2. Does this make sense? I hope it does. But there's one more thing. In C++, check this out. I'm going to go ahead and create yet another main method. So this one is going to be old part 3. And I'm going to go ahead and do this. Return 0. So in C++, see, this behavior is the default behavior actually. Look, in Java, if I were to write system out copy constructor code, see, if I run this code, it says copy constructor called because of this line over here. If I were to just uncomment this one and comment this one, then the copy constructor isn't called anymore. Cool? Okay, so in C++, there is a default copy constructor, but we're not seeing it right here. Let's do the same thing as we did here. So how is this gonna look like? Product, which receives. Actually, this one is gonna be a constant reference because we're not gonna change the parameter. Product, it's gonna be a reference. Why create a copy right here as a parameter? I don't want the parameter to be a copy. I want to create a copy based on the parameter. So this one would be another object, right? So let's see out copy constructor called and line, and we're gonna do pretty much the exact same thing that we did in Java. Let's write it in C++ fashion. So for the new object to be created, the name is gonna be the name of another, and for the price, it's gonna be the price of another. Make sense so far? Hope it does. So I'm gonna go ahead here and create not a pointer, just a regular object. Product P1. And I'm gonna name this one pizza, just like I did last time. Okay, maybe change the price a little bit, see? Let it be $9.99. Let's hope pizza does become in fact cheaper. And I'm gonna go ahead and create product P2, which is gonna be P1. Now, what do you think? What are we gonna see on the console? So obviously this one calls this constructor over here, but is that it? We shall see. I have this crazy theory that this is not gonna be the only thing that we're gonna see. Check this out. Ta-da! See, when I go ahead in C++ and write, I want a variable to be another variable. This equals that. C++ by default creates a copy of the element. So this is actually the reason. See, I didn't invoke it explicitly like I have done so in Java. But C++ creates a copy nevertheless. If I were to change P1 set price to $19.99 and then P1 to string, I'm gonna call P1 to string and P2 to string. Check this out. We're working with copies here, right? Ta-da. Does this make any sense? I certainly hope it does. However, let's try one more thing. This one is gonna be main invoking copy constructor. Let's do the same thing, but let's work a little bit with pointers. What do you think? So I'm gonna go ahead and create variable p1 as a pointer. So I have to write like this, new product. Now here's the interesting part. If I'm writing product pointer p2 equals p1, so this one, just like before, is going to go ahead and call the constructor with two parameters. We're going to see this in the console. What do you think? Are we going to see the copy constructor being invoked? Now, remember what Java did? And in Java, everything is a pointer, right? For this case, Java didn't call a copy constructor, right? And this one is the case for pointers. Should this one call the copy constructor? What do you think? Let's run it. See? No constructor being called. Why? Because p2 is not a copy of p1. It's simply a pointer pointing to the same memory address as p1 did. Check this out. p1 to string, p2 to string. And before I do this, let's change the price for p1. Let it be $29.99. Very bad news for pizza lovers. Check this out. So basically, both of them change. Why? Pointers deal in memory addresses. In this case, pointer p2 points to the same address as p1. They are sticky. If I were to change p1, it changes a product that p2 is also pointing to. See? Here. I know nobody reads the comments, but I think this one is a little bit more interesting. So, what do you think about copies so far? What do you think about this whole mechanism and the comparison between Java and C++? Let me know. Oh, one more thing. One last thing, I promise is going to be the last one. But I wanted to leave you a little bit of a homework, so to speak, to do. I'm curious about something. See, like we created this product over here. So basically we have p2, which points to the exact same address as p1 does. It is the same address for all intents and purposes. Look, we can have an experiment to check that out. If I were to write this address of p1, and I can just display p1 because it is a pointer already, and I'm gonna go ahead and write address of p2, and I'm gonna display p2 just here. So see, it coincides, you know what I mean? So, is there any way in which I could use this p2 variable to change something about it in this line of code over here for p2 to not be the to not point at the same place as p1 does? Could I invoke the copy constructor for p2? And if so, how could I do that? See? So if that happens, then if I set the price on p1, the price on p2 doesn't change, right? So tell me what you think.